Today, we are going to discuss about how I extracted the in-plane irradiance, plane of array irradiance component from PV library. Mm, like what I did is, I have extracted the POA for this data set, weather monitoring system data set, which is which consists of following features plane of array irradiation, which is in watt per meter square. This is a measured one from the plant data, GHI, battery voltage. They have used a single panel. They have measured battery voltage of it and panel temperature, related humidity, wind speed, wind direction. They have measured. For this one, I have added the plane of array radiance from the PV library. Like this data is of 15 minutes time interval. Mm, and based on the location, altitude and longitude and 2017 data. So I have used these data for extracting the POA from PV library. Next, extracted this for study the impact of weather parameters on panel temperature and battery voltage. For extracting plane of array irradiation from PV library, this calculation is important for modeling the performance of PV system. We can also develop Sandia model for analyzing the performance of PV system. But now I did this first these two are the important parameter for this calculation, defining or determining the orientation of the array, which is either fixed or trackable one. The panel is either fixed or trackable one. Based on that, we should extract the data and estimating the contribution of the beam and diffuse irradiation component. Diffuse irradiation, sky diffuse, ground diffuse, which we have seen in before classes. Tracking arrays are of two types. One is single axis tracking and other one is dual axis tracking. Single axis tracking, it's move back and forth in one direction, which follows the sun from east to west, while dual axis tracking, it can travel in two different directions and changes the position according to the season. To extract the maximum possible energy from the sun, dual axis tracking can be used, but it's a bit costlier. Mm. These tracking arrays are designed for warmer climates with little or no slope, while fixed drag better for harsher climates. First, I have imported the libraries, and then I have here you can see I have calculated the solar position. This one is available in PV library. Here I take this as an example. Solar position, get solar position. First, I have initialized the latitude, longitude, and the location, and then the time range for example, if I take winter season, it's from January to February and 15 minutes time interval. These things and I have assumed, and then for solar position, I have used this one. Many things are available in PV library to calculate solar position. This is one among them. Um, and then stage it's of solar position. Then it's for irradiation data. One second. I will open the link. I think this one is visible. For
Yes.
calculating plane of array radiance, this is a combination of beam, ground reflected, and diffuse sky diffuse. For plane of array radiance, beam radiation, it's of multiplication of DNA into cos angle of incidence. These are the calculations which we have to do manually, but in PV library, there are different functions are there so that we can use it and extract it, like GHI, value, DNI, and those things. Like finally, I came for in-plane irradiation components, which consist of multiple steps. Here we can see the code, Python code, like it includes angle of incidence, irradiation data, that is the DNI, and then sky diffuse, and then finally ground diffuse. All this we have to calculate, and then finally we can get the plane of array irradiation global value, which is in watt per meter square, which is the irradiation components which we required. Like this is the final plot which we discussed in the last presentation. This is the one which we need. We can extract it in Excel or CSV file. So here we can see the Python codes, how I did it. One second, sir. It's loading. Like, shall I run it or shall I discuss it a little? Sir?
That codes you simply discuss,
Okay, sir.
uh, then you can run it.
First,
Means not this basics, no need. That you just see this location. That is
okay, sir.
that line only.
Like,
Yeah.
okay,
So
right.
there
First
are some
in
basic. I will tell them. There are
okay,
some basic things you need to input that you will learn in a later stage. How you are opening the Python libraries for pvlib accessing, then you have to go for the specific code. You can Ananti can focus on that specific code. Okay, you proceed. Yeah.
okay, sir. Okay, sir. Like first initially I have installed and inputted things which are required for operation, and then this one we are seeing in the presentation. Like here we can see I have the 2017 whole year data. For that we can extract from 1 January till December at 15 minutes time interval. And it's the power plant is located in Bellary, and this is the altitude. This is latitude and longitude, which comes under India, which is located in Karnataka. Like these are the remaining things. The solar position, get solar position. This one we can use, and here we have extracted and plotted the things which comes under solar position value. Then I have used get clear sky one, so that we can get the irradiation data. Here we can see that GHI, DNI, DHI, that things are coming for the whole year. That data is available. Then for that in-plane irradiation components, we have to calculate angle of incidence. For that, based on the location, I have named it as A. Here you can see that location A, latitude and longitude. Uh, we can consider the solar zenith and solar azimuth which we calculated before, and we can calculate the angle of incidence. Then um, then we have calculated the ground diffuse using these data. Albedo is nothing but ground surface reflectivity, and then remaining these things, that GHI, and then latitude, we can calculate the ground diffuse, and then sky diffuse, like get sky diffuse using this function. Like we can get sky diffuse value. Then this is the final one. Like we can use all the thing which we calculated, like angle of incidence, irradiation data, the DNI, sky diffuse and ground diffuse. We have extracted that plane of array radiation global value for the complete year. Um, like this is the plot of it. Here we can also, um, using this code, we can convert that into a CSV file and download it, and we can use it for further purpose. Um, like this I have did it, and finally this one we have seen already. Like I have compared the plane of array irradiation of this one is a measured value from the power plant data. This one is this red dot represents the predicted value from the PV library. You can see the difference. This one is for winter season. Similarly, I have plotted for summer season. Um, this is for monsoon and post monsoon. Um, that's it, sir. Till now, I've prepared this one. And, hello, am I audible?
Fine, very good. Ah, yeah, fine.
Ah,
Mm,
yes, sir.
okay. So, if you have any uh, questions, you